Good morning, everybody. Let's get started on this 7.2.3 out of the CPM book. If you like page numbers, this is page 341. Let's go ahead and add that to our heading. And then if people want that, they can use that. Again, using your book, that's handy. Using your book or the ebook, knowing that it's lesson 7.2.3, right? Second section of chapter 7, third lesson. And write the problem numbers. Again, I want to emphasize now when you're using writing the problem numbers, write that right parentheses around the number and even the letter. If, like in this case, there's A, B, and a C. Why? Because you want to separate the name of the problem number or letter from the actual problem. We're using letters now, and you don't want to be confused at all. Make it as simple as possible. And putting that right parentheses really helps you out on these problems. Okay, get used to that. And again, this easiest 3 points, we've timed ourselves. It takes between 30 and 45 seconds for most people to write a complete heading. Okay, and make it as easy as possible on you in the long run by spending that 30 to 45 seconds. Along with, don't lose any points. It's silly to do that, right? And you'll find that if you do this for like a week straight or 2 weeks straight, pretty soon you do it out of habit. What does that mean? When you have a habit of doing something, you end up doing it without even thinking about it. Now, that's good and bad, right? If you have a habit of chewing your fingernails, you do it without even thinking about it. Someone has to tell you, hey, stop chewing your nails, right? If you have a habit of brushing your teeth, on the other hand, you do it without even thinking, right? You could be spending your brain, your conscious thought, on all sorts of other things, maybe practicing your facts, right? Your 6s, 6, 12, 18, 24. But your subconscious sort of takes over and kicks in, which is kind of cool. Okay. And that's the idea, to develop good habits. And that can only happen by repeated effort, from repetition. Okay. Mr. Whitney will tell you repetition is the mother of success. Okay. All right. Let's get busy. We're already 2 minutes into this video. First problem is 4 1/3 divided by 1 1/6. All right. Now, what are we doing? We're dividing fractions. Okay. Now, what does Miss Nortz teach us about dividing fractions? Same, multiply, flip, right? Smell my feet. Leave that first number the same. Now, I'm going to leave it the same and show you 2 steps. Now, instead of divide, that M stands for multiply. Why? Because multiplying fractions is what? Easy, right? And instead of 1 1/6, I want to flip, but do not flip 1 1/6 to 1 6/1. What we have to do is use the C method here and know that 1 1/6 is 6 6 plus 1 6, 7 6, right? That's the same as 7 6. Now I'm going to flip that and have 6 7s. Okay. Now this here, I still need to deal with that, huh? That's a mixed number, and I can use the generic rectangle and have 4 1/3 times 6 7s, or I can go ahead and use the C method on this as well and turn this into an improper fraction, right? 3 times 4 is 12 plus 1, 13 over 3 times 6 over 7. Now, again, our goal is to always make our problems as easy as possible. And we are allowed to do that, right? If there's an easier way of doing something, I recommend you try it, right? So what am I talking about here? I'm talking about something called cross cancel. Do you recognize anywhere in this multiplication problem where I can make it easier? Okay. Well, hopefully you recognize that a 3 goes into the 3 here, but also fits into 6 on the top here. So I can simplify before I start. That's called cross-canceling, by saying 3 goes into this 1 time and 3 goes into 6 2 times. Now my problem becomes 13 times 2 on top, 1 times 7 on the bottom, 26 sevenths. Now that's improper. You usually don't want to leave your answer improper, so let's go ahead and divide the bottom into the top there. We'll go ahead and cross out that B and bring it down a little lower. 7 goes into 26 3 times. 3 times 7 is 21. When I subtract, I get a 5. And remember, my remainder is going to go on top. My divisor is going to go on the bottom. So my answer ends up being 3 5/7. put a circle around my answer, put a big box around all of my work on that problem. So I know exactly where all of my work happened. And now I'm going to go on to B. Okay. All right. Now B is a little tricky because we haven't really dealt with dividing with a decimal as the denominator or as the second number, or what I say, the number that's outside the box. Okay. So I'm going to tell you what to do quickly and help you on this, but we will be dealing with this in the warm-up this week and probably a pizzazz worksheet later in the week. Okay, when you're dividing with a decimal outside the box, inside the box it's no big deal. You just bring it up and divide. But outside the box, it becomes a bigger deal. Okay, we have to actually get rid of it. Okay, you cannot divide with a decimal outside the box, and if you do, you're breaking the math law, and the math police will come and get you. You'll hear the woo, 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 and the math police will come and get you, and you don't want that. Okay, so you cannot divide with a decimal outside the box. We have to get rid of it. Now we know if I want to get rid of a decimal outside the box or any decimal, I need to move it over so it is on the far right. If it's on the far right, I no longer need it and I can get rid of it. But here's what you have to know. If I move it 2 spots outside the box, I have to move it 2 spots inside the box. If I move it 1 spot outside the box, I have to move it 1 spot inside the box. If I move it 3 spots out, and I'm going to show you why real quick. Okay, I'm going to go do this. Now remember, all fractions are division problems. So what is this? This is 8.06 over 2.48. Now, if I were to move that over 2 spots, that's like multiplying it by what? It's like multiplying it by 100, right? Well, if I want this to be equal, the same as, I have to have 100 on top as well. So I move that over 2 spots. Okay, whoops, almost put that decimal there. So 8.06 over 2.48 is the same as 806 over 248. Okay, now I also want to tell everybody, whenever you do write your problem out and then start moving decimals, right? Different number of scoops and stuff. I want to emphasize that you want to take an extra 5 seconds. And before you start dividing, after you have all these scoops and all these decimals, right? I got 4 scoops and 4 decimals. Okay. That is a messy looking problem right now. And messy oftentimes leads you to make mistakes. So spend an extra 5 seconds and rewrite your problem before you start dividing. Okay. What does that mean? Well, if I moved it over 2 spots here, 2 spots here to make this 248 divided into 806, just write 248 divided into 806. Boom. That took less than 5 seconds. But now when I start working on this problem, I'm much less likely to make a mistake than I'm working on this problem. And they really are the same thing. Okay. Again, we will go into more detail of why we do this and how this works, and a fun way, I think, to remember what to do there. Okay. Now, what you're going to do here, you're going to divide. Okay. Now, if I'm estimating this about 250, I know 250 3 times is 750, and 254 times is 1,000. Why? Because it's like a quarter and a dollar, 4 quarters and a dollar, 25, 50, 75, 100, right? So I'm already saying that this is going to be 3. Okay. And then I'm going to multiply, and then I'm going to add a decimal, bring it up, and add a 0, right? And hopefully this will fit in there a round number of times, and I don't have to go too far out. Okay. But I'm going to let you try to finish that. It's a tough division problem. Okay. But I think I did the area that you probably weren't aware of how to do. Okay. Okay. On to this one, right? We're still on the first problem, and we're 9 minutes into this video. Okay. 3 2/5 divided by 1 3/10. Now I know I'm going to go smelt my feet on this, right? Let's go ahead and change our mixed numbers to improper fractions using the C method before I write it out. Okay. 3 2/5, that's 5 times 3 is 15, plus 2, 17. 17 fifths. And instead of divide, I'm going to do multiply. Why? Because multiplying fractions is, you yelled at that time. Now, I'm going to go ahead and do this real quick because oftentimes in these type of problems, if you try to do a shortcut, you end up just putting this here instead of putting what's there should be flipped, right? So 10 times 1 is 10 plus 3 is 13 over 10. So that is 1 3/10. Now, when I flip that, I have 10 13ths. Okay? All right. You can cross cancel. That's a hint for you. And I'm going to have you finish that problem. All right, 7-65. Find the multiplicative inverse of each of the following numbers and refer to the math notes box. And the multiplicative inverse. What is a synonym for multiplicative inverse? Check this out. Multiplicative inverses and reciprocals. Okay, what is a reciprocal? Well, a lot of you will look at that F when you think reciprocal. And if you did this morning's warm-up, or yesterday morning's warm-up, you'll remember, right? We introduced it yesterday, and you got more practice today, and hopefully they're starting to get easy. Reciprocal is a word that's kind of long and hard to say sometimes, but the more you use it, the more you'll own it, okay? And all it really is the number that you multiply by the other number to get 1, okay? What does that mean? Well, a fraction, what is the reciprocal of 3 over 7? It ends up being 7 over 3. Why? Because 3 times 7 is the same as 7 times 3, and the same number on the top and the bottom equals 1. So the reciprocal of 3/7 is 7/3. Now, 7/3 is an improper fraction. Sometimes you will see that as 2 1/3. It's the same thing. Be careful when you see 2 1/3 and they're asking for the reciprocal of that. It's not 2 and 3 over 1, right? You got to go make it this, then flip it over. Okay? Hint for you. Now, having said that, I think you can find the reciprocal of 7/8. Okay? And 1 2/3, I will do the first step for you, right? The C method. 3 times 1 is 3 plus 2 is 5. So the 1 2/3 equals 5/3. Now find the reciprocal of that. Okay. Now 1.5, is there another way to write that? Yes. 1 1/2, which is 3/2. Now find the reciprocal of that. 25 hundredths, what's the reciprocal of that? Well, I'm going to simplify that. 25 hundredths all the way down to 1/4. What's the reciprocal of that? Okay. So I'm going to let you finish those. I don't think those will take you longer than about 1 minute to do all 4, probably, okay, at this point, okay? Unless maybe you skipped the warm-up yesterday and today, then they might be a little bit harder. All right, this 7-66 looks like something I should probably do on the back, or can we squeeze it in, okay? The giant 1 lets you change a decimal division problem into a whole number division problem, okay? And that's another way of dividing these fractions, right? And you can see how they multiply it by 100 over 100. And basically what you're doing, you're moving that decimal, right? The decimal on the bottom is the most important one to get rid of. You could still have one on top, but on the bottom, you have to get rid of it. So I had to move it 2 spots here. They multiplied it by 100 over 100. Sorry, I'm a little bit off the page there. This is what we were looking at. Okay. All right. So we want to copy the example and complete the other problems the same way. Okay. So I'm going to pause this real quick and go ahead and write out that table so it doesn't get added to this already kind of long video. Okay. I'll see you in a bit. All right. So I wrote a few things down. This should help us a little bit. One thing, flip it over, right? When I get to the left-hand side of the page in the book, I should flip the book over to this side so you can see both the book and the paper. I pretty much copied this chart down over here. So we're doing these division problems. And again, they're teaching it with the magic 1. I only filled out this first column, the original problem. I'm going to show you. We're going to go through it. So if I want to get rid of that decimal in the denominator, I have to move it 2 spots. Well, what value of 10, what power of 10 do I need to multiply this by to move it over 2 spots? Well, it's 10 to the second power, or 100, right? So if I want to move it over 2 spots here, I have to move it over 2 spots there, right? And I fill in the egg card. Now, how are we doing that? Well, they are trying to show you that you're multiplying it. And again, the key is you have to get rid of the decimal on the bottom, the denominator, right? So I have to move it over 2 spots. I have to multiply that by 100. And if I do the bottom by 100, I have to do the top by the 100. Now, you remember why they call this the magic one or the giant one, right? I think I call it the magic one, right? Because 100 over 100 equals 1, and you can multiply any number by 1, and you're not changing its value, which is what we want. We don't want to change the value, but we want to make the problem something that we can work with. So 0.25 times 100, remember, you're not adding zeros anymore. That's what you did in 4th grade. Now we're thinking I move the decimal over. Why? Because it really helps us when we multiply decimals by 100 or 10 or 1,000, right? Move it over twice, I get 25 on the bottom. On the top, move it over twice, I get 250. So my problem now ends up being, remember, the bottom number or second number goes outside the box. And 25 goes into 25 once. Multiply, bring down, after I subtract, bring down the next number. It goes into 0 times. So your answer is, yes, 10. Okay, that's what you're going to do on these. Okay, now what value of 1 do I have, or 10 do I have to multiply a 0.7 by to get rid of that decimal? Well, how many spots are you moving the decimal? 1 spot. So it's the value of 10 is 10 to the first power. Okay, here it was 10 to the second power because I moved it 2 spots, and 10 to the second power, remember, is 100. 10 to the first power is just 10. So I'm multiplying both 1 and 4/10 and 7/10 times 10, because this is 10 over 10, so this equals 1. Same thing on the top as on the bottom. 1 and 4/10 times 10, move the decimal over 1 spot, that's 14. 7/10 times 10, move the decimal over 1 spot. So now I'm dividing the bottom into the top, and 7 into 14. If you know how to divide at all, you give me that answer. Okay, next problem. How many spots do I have to move this decimal to get it over here? Well, it looks like 1, 2, 3. So that's 10 to the third power. 10 times 10 times 10, that's 1,000. So again, 520 over 13 thousandths times 1,000 over 1,000. Same thing on the top and bottom. Bottom's easy, move it over 3 spots. That becomes 13. The top, 520 times 1,000 is 520,000. So now this ends up being a little bit of a long problem until you remember a deck of cards has 4 suits and 52 cards. There are 13 cards in each suit. 13 into 52 is basically your problem. Then you're going to have some zeros in the end. Okay, I'm going to let you finish that. Now, same thing here. I want to move it over 1 spot for the second number. I got to move it 1 spot for the. Now, we could write this like this if you want, I guess. Okay, rewrite it as a fraction. That's what the book does. Okay, and again, 1 spot means I'm multiplying it by 10. If there's a 10 on the bottom, there has to be a 10 on the top. This ends up being 82 divided by 4, or 4 into 82. Okay, second number, how many spots? 1, 2, 3. So 3 spots is 10 to the third power, which is 1,000. And again, 2 hundredths over 5 thousandths times both by 1,000. Now be careful here. Move it over 3 spots. That's 5. When I move this over 3 spots, I end up with, I got to fill that egg carton. That's 20. So not 2. 5 into 20 on that. And again, if you know anything about dividing, that's a basic fact. Okay. All right. Second number. Decimal needs to move over 2 spots. I'm going to let you do that one by yourself and see if you can do this step on your own, as well as convert it to here and get the answer. Okay. Now, 7-67, these are checkpoint problems. We have done enough of these that I'm going to let you go on your own on all of these, okay? Do these on your own. I do recommend using the C method on this, on C. Use the C method on C. Don't use the B method on B. There is no B method. Cross cancel, though. Now, on E and F, remember, pretend there's no decimal, multiply, and then figure out where you're going to put the decimal by counting how many spots you had to move the decimal in the problem. Last problem. This graph is showing how many gallons of gas a car uses and how many miles it goes. And when you look at the graph, it looks like on 2 gallons, it goes between 50 and 75. It's more than halfway. I'm thinking that's around 60, maybe. But if it was 60, then 4 would be right at 120. That's over 125. So maybe 62, 63, 64, right? 63 would be 126, a little bit more than that. So I'm thinking maybe 64 about, maybe. Now, how do I predict 3? Well, this is what's called a linear function. You should get the same amount of miles for every gallon, right? So this should pretty much make a line. So if we make a line here, okay, it looks to me like for 3 gallons, it would get about 100 miles, right? It's on that line. And for 5 gallons, it would get, I'm going to let you decide. Okay. Now, what I always want to do on this problem, though, is I want to find the rate. How many miles per gallon? So if I'm thinking this 2 up here looks like about 64, if it looks like 64 miles for 2 gallons, what is the rate? Divide the bottom into the top. How many times is 2 going to 64? That ends up being 32. So I'm thinking my rate is about 32 miles per gallon. Okay. And let's just see. When I looked at the graph, it looked like 3 was going to be about 100. What's 3 times 32? 96. That's pretty close. Okay. So answer these two based on the graph. Okay. And if it wants you to explain. But that's kind of what we're doing. Okay. Kind of cool to see that. All right, everybody. Sorry for the long video. There's a lot packed into this lesson. Kind of fun problems, though, huh? Hopefully you had fun, too. All right. Have a good one, everybody.